Hello everyone, my name is Molina, and today I will be giving a presentation on deep learning applications in cybersecurity. So first I want to introduce the problem statement, which is how can deep learning models assist in tackling the issues that cybersecurity faces? This paper aims to answer that by stating that it is more efficient, more cost effective, and more elegant than current cybersecurity solutions in the detection of different problems. So the paper in question is Deep Learning Applications in Cybersecurity, a Practical Approach. It was published by Science Direct, and the authors are available to see right there. And this paper was built upon 36 different reference papers, basically using all of their research and applying it to 3 specific scenarios. So, for the first scenario, we have spam filtering, specifically SMS spam. And the model that the researchers chose to use was RNN architecture, specifically LSTMs, long short-term memory models. And what these do, or what RNNs do, is they process data sequentially, meaning that compared to something like CNNs, which we're more familiar with in this class, which has things broken down by pixel and convolutes different regions over time, this processes the data linearly. And the researchers specifically chose RNNs because they're well suited for text recognition because of their linear processing, and because they maintain context using memory cell, and they can also have selective memory with gates in each cell. And the reason that this is important is because it can take training that was relevant for other messages and apply it in current messages. So basically RNNs are just the ideal model for text. For the second scenario that this paper covers, it is malicious software detection. And the scenario was all types of malware. So on the right you can see the different types: spyware, worms, ransomware. And they chose to use DNNs for this scenario, which is basically a multi-layer perceptron that has hidden layers. And how it is trained is through backpropagation and adjusting these parameters iteratively until it gets the right ones with the highest classification rate. And the reason they chose DNNs is because of the abundance of available malware samples and the potential for high accuracy with complex data, which is important in this case because it's analyzing a bunch of complex files and a bunch of junk code basically to find suspicious content and label it as malicious. The third scenario is adult content filtering, and the scenario was NSFW image detection. The model the researchers chose to use for this scenario was VGG16, which uses CNNs, which, as I said earlier, basically segments the image by pixels and convolutes different regions with filters. And they chose CNNs, or VGG16 specifically, because it learns complex features invariant to spatial transformations. Now, this was extremely important for this scenario because the dataset that they used, which is NSFW images, have a lot of spatial transformations, such as being dark, blurry, and tons of different angles. So CNNs were important to use for this scenario. Discussing the results, they got an area under the ROC curve greater than 0.94 for all 3 scenarios, which is extremely good. And the area under ROC curve is basically a measure of how well models were able to classify something on a scale of 0 to 1. So 0.94 means it was classifying correctly if something was malware or not, a majority of the time. And these scenarios matter because security has always been a major part of computer science for one, and it impacts anyone that uses the internet. Cybersecurity is an issue for anyone that goes on any form of software or website, so it's relevant to everyone. And to conclude, as I said, it was accurately labeling and classifying everything, despite its limited dataset in every scenario. So this was the main problem with this paper. All of the datasets were very limited. So for example, for spam filtering, they only had 5,000 aside images, or not images, text, which is very small for their case. And despite this, of course, they still had a very good ROC curve, or area under the ROC curve. And what this paper can do is basically lay the groundwork for future improvement, whether that be on the models used as this paper, for example, getting much larger data sets, or as a benchmark for other models for future papers, which you can compare models. So if you wanted to use a different type of VGG, or say GoogleNet or something else that we've learned in this class, you can compare it to this paper and see if you can get a greater area under the ROC curve. And that concludes my presentation, and if there are any questions, you can find me on the People tab on Canvas and email me through there. Thank you.